Hello again. Now we are in segment 3. Segment 3 is all about assembly. So let's quickly start our question number four. Number one is we have a base part, so we need to create this following part and with these dimensions. Okay, let's start our part. We have a base shape 200 and 120. Let's go to and open a new part. Let's click OK. On the top plane and open a new part, center point rectangle. So don't forget to change to IPS to MMGS. So we have 200 now and 120, 120 and enter. And so we have fillets, a couple of fillets. Let's try to give those fillets, and this is 10 probably. Windows selection, right click. And let's click OK and go to features, extrude, and as you see 125 millimeter up. Just type 25 and enter one more time. So we need to cut this side, so let's go to top plane again. We could create the same sketches on boss extrude one, but again it's all depends on how you start the part. Okay, so these are 60 60 60 60 again, so 120 for this side, 120 for this side as well. So this is 60 and enter. So this one and this one is equal. Okay, we'll cut those. Let's create circle again. The diameter is 20 and enter. Actually could be good to what I see, because we need to add this. We have a through hole over here. It could be good to start first this shape, but anyway I am closing this. We can start now. Let's go to boss extrude on this face, a hole again. The diameter of the hole is 45. Go to features and extrude, and we have 15-degree draft, and overall height 25, and we have overall 40, so we need to type 15 and enter. Let's click OK. So you just remove the sketch tool after extrusion. So let's go to extruded cut extrusion. So sketch contour, I select this as well, this one and this one. So right click, through all, other side. Let's click OK. So in 3 steps we have completed this, so we need to add this cut. Let's go and select this face, the line from here to here, right click and select, and the height is 12.5, enter. Distance from here to this point is 60 again. Go to feature, cut extrude one more time. We'll have us through all, and other side, flip side to cut. We need to get rid of this portion. Let's click OK. So we have completed our part. As you see, we don't have any problem at this point, but only we need to give these fillets 10 millimeter fillets to inside. Let's go to fillet. Let's check this one. If we check first, this is connected one. Yeah, this internal feature, other 3 edges. So we have added those. The material should be brass. 2 decimal places. Let's go ahead and select plain white just to clearly see our part. So we need to save our part. So save base 1, something like that, and click OK. So we have only base 1 over here. So what is the first question? First question is, what is the mass of the part in grams? Let's go ahead and check our part in grams and add over here. Later on we will check if they are correct or not. Okay, the second, we need to create an assembly based on this part. So let's go to position is arbitrary. So we need to create a new coordinate system over here. Let's click this and make assembly from part. And let's add our part over here. So we have added our part. So we need to create a new coordinate system. New coordinate system to this edge. So let's turn our part and go to reference and coordinate system. So we need to just click the point in order to insert our new coordinate system y, x and z, x and y. So let's click OK. So we have created our coordinate system. Hide our coordinate system or show a coordinate. If it's not shown again, you need to go here. You need to check to view coordinate systems. Okay, this is correct now. What is the central mass of an assembly? Let's go to properties. From here, instead of default coordinate system, we need to select coordinate system 1. But first of all, again, don't forget to change to mmgs. One more time, coordinate system 1. This is our current coordinate system that we have. So 95.68. Don't forget again, change to decimal places to 2. Then you will have again correct central mass. Add over here. Let's delete this. Okay, now this is correct. So we need to save our assembly. Let's type main assembly. Main assembly and click save. Again, we are in question number 3 and we need to add arm mount to this assembly. So let's go ahead and insert components and we need to browse. So arm mount, check yes, arm mount and click open. Let's add arm mount over here. And as you see, we have a couple of relationships that we need to give: concentric relationship, parallel relationship, and coincident relationship. Let's first try to give this relationship, concentric relationship, and we need to turn around this side and let's try to select the face and hit the control, select this face and select coincident. And again, one more time, let's add parallel relationship, excuse me, to add a parallel relationship, and this is fine. So this is our assembly now. And then what is the central mass of the assembly? Select, and this is the central mass of an assembly. Based on a new coordinate system. Okay, so the next we need to add arm, lower arm, and arm center between the tabs. And width mate, we need to give one of the advanced mates a width mate. Okay, let's go to insert components and browse. You can add the lower arm. Okay, over here. Just add. Okay. So we need to add our lower arm to this concentric with concentric relationships, and this needs to be parallel. Again, let's turn it around. Just right click, hold the right click, and turn your part to this side like that. Okay. Let's select this and this, make them concentric. So let's go to mate, and again, instead of standard mates, we need to go advanced mate and select. We need to select width mate. Go to width mate. We need to have width selections, and also tab selections. Right click and close this. So we need to give the parallel relationship like that. So I believe we have completed this Yeah, parallel to this one and concentric and width to this. So let's check our part of center of mass again. Put the center of mass over here. Okay, let's go to next question. Collision detection. Delete the parallel relationship from question number 4. Okay, we have given parallel relationship to this or this, and you need to, in order to find that, just click this and you will see the parallel relationship, then suppress it. So now part is free to move. So we need to perform collision detection. So use the collision detection. We stop at collision turned on. We need to stop over here and find what is an x-axis, x degree. In order to do that, we need to go move component and collision detection, and stop at collision should be selected. And I select this and go down, and you will hear a sound at collision. Let's click OK. Let's go here and turn the part, and let's go to measure, select the face and select this face, and the degree between them 11.8 degree. Let's go here, let's add a degree over here, 11.8 degree. Close the part. So next part is create a new assembly, and this will be a sub-assembly to the main assembly. So the new assembly will be referred to as shock. Okay, we have this part, and which one? Yeah, we need to add a shock housing to our assembly. So let's go ahead and create a new part, assembly, and click OK. Okay, we need to browse. We need to select our shock housing and click open. So we have added our shock housing. Turn our part. Okay, we have shock housing. So we need to save this as a shock. Save. Okay, and we have created this. What is the mass of the shock assembly? Let's go ahead and click this, and this is the mass in pound. Don't forget to change it millimeter again. I always forget. Options. To select this, add over here 117.32 grams of the mass of this shock housing. Let's move to next question. So we need to add a piston to sub-assembly. So and we have this relationship. So let's go to insert component, browse, select piston and click open. Let's add piston to over here. We need to give concentric relationship first of all. So let's try to see inside face. Click inside face. First inside face, it's hard to see. Select all these and mate them with distance mate. Distance should be 40 millimeter. Let's click OK. Click OK one more time. Let's select and see the transparency of the part. Yes, we have correct dimension now. Let's select this and this, make them parallel. Okay. What is the question now? So what is the mass of the shock assembly? Let's save our assembly first and check the mass. 358.19 grams. So this is our answer. So answer is C, means this is correct, and probably the previous one was correct too. Let's move on to our next assembly, next question. So it says adding a sub-assembly. We need to add sub-assembly to our main master assembly. No modifications to shock assembly should be made. So we need to preserve this 40 millimeter distance. Let's go to window and main assembly. We are in main assembly now. Insert component, shock. Let's add our sub-assembly over here. Okay, so we need to, as you see, we need to add upper arm and knuckle as well. Let's go to insert component, browse, and upper arm, and also knuckle, and open. This is the first one, and this is the second one. Okay, now this is the view is better now. Okay, we'll add a concentric relationship between these two, but first of all, let's add this concentric relationship. Oh, excuse me, this and this. But they will be the same actually. So we need to add again width mate, advanced mates, width mate. Select the width and tabs again. This time doesn't matter which one you select. Okay, check this. Let's add again concentric relationship between them. Check our part. Okay, we need to add upper arm, we need to add knuckle over here. Let's turn it around, move it over here, select the face or edge, doesn't matter, and again width mate we need to give advanced mate, not profile center, and width selection. You can select inside face as well, doesn't matter. Right click. So we need to give width mate to these two. This profile, this profile, to this profile, and also this profile. Oh, we are in. Okay, we forgot to select advanced mate. Okay, let's turn it around. Let's first give the symmetric relationship this coincident relationship. So now we can go to standard mate instead of standard mate, advanced mate. First is width selection, clear all, this one, and also this one, tab selection, this one, and also this one, and okay. Okay. Again, let's go to standard mate, this cylinder, and this one, make them coincident, and click OK. And click OK one more time. If I want to move the assemblies, it should be fixed now. Now it is fully defined, you can see over here. Let's check what is the question. So what is the central mass of an assembly? Let's go to mass properties. This is central mass of the part of an assembly. Let's check our answer, 79, 42, and minus 30. So this is the correct answer. Interference detection. So next part is interference detection. Change the distance between the piston and shock, as you see like that. Note that the distance mate has been flipped. We need to flip the distance mate. And then we will use interference detection to determine collision between the parts. Okay, the only box that should be checked in the interference detection option is make interfering parts transparent. Okay, let's go to, in order to move that and check the distance, we need to select the part, but first of all, right click, go to the properties of subassembly, not face properties, we should have a properties of assembly. Okay, we'll do this window, shock, right click, should have a properties of an assembly. Okay, we'll do over here main assembly, where we'll have a shock, right click, go here, you will see probably, yeah, we'll use replace components later on, but we need to see assembly properties, subassembly properties. Okay, well, I'll check this later on because we need to make it flexible, otherwise it will be fixed. So this is not flexible now. Let's go and select and try one more time. It should be somewhere over here, but anyway. Subassembly. Okay, let's try to change it. We can change from here, or we can select open a part like that, or let's try to open the shock assembly first. So dimension is changed now. Make it transparent. We need to go the distance made and edit distance made. Distance is 10 millimeter now. Check 10 millimeter, but the dimension is flipped. So we need to flip dimension to outside. Let's click OK. Click OK one more time. Okay, we have changed our part and it will automatically update in main assembly. And then you will see the part is updated now. Let's go ahead and check interference detections. So interference detection, we need to go to Evaluate tab and select interference detection. And main assembly, you will see the main interferences. So and the question says that the only box that should be checked, these box should be checked, the interference detection option is make interfering parts transparent. So make interfering parts transparent. So as you see, we have only these parts interfering each other. So well, we need to check piston and housing. So we need to see this as well. Yeah, we have this interference with lower arm and piston, and also we have knuckle. We have interferences over here as well. And the next one, this one, probably this is this side, and this one is the other side. So we have 4. So answer should be checked. And knuckle and upper arm and the lower arm, with I think except base and with the shock housing, we need to check all of them. Okay, the flexible assembly, flexible subassembly. So we need to create a new part, and it says suppress the distance mate in shock. Well, suppress the distance mate, and that will allow the piston to move inside of the shock housing. And flexible in the top level assembly. Okay, let's go to assembly, select this one, uncheck this, select we can select from here as well, distance made, and suppress. Okay, click OK. We need to suppress the distance made now. Click this, then this is fine. So we have suppressed the distance made, but we need to select again. Okay, so we need to make our part assembly flexible, and we need to add this. So let's first make our shock flexible assembly. So let's go ahead and check make subassembly flexible. So flexible means now we can move the part piston like that. Okay, let's go ahead and check a new part, create a new part. Click this and click OK. So the dimensions 50, 22, 3, and 8, and 15. Change it to millimeter, the front plane, and we need to create a new part. Right click, start from here to here. (22) from here to here should be 15 from here to here should be 8. Overall 50. And this should be coincident. And thickness should be 3. Let's add the chamfer as well. Chamfer distance is 2 millimeter now. Click OK. Features and revolve. Let's click OK. What is the material? Plain carbon steel. Let's go right click and plain carbon steel. Save the part. So name of the part should be just new part. Spindle. Let's go to main assembly. Let's add our part to as it is given. Just turn it around. And give the mate like that. And also concentric mate. And this is fine. So one additional mate should be made is 10 degree from this edge at this side, this face, and this face. Let's give the angle relationship and click OK. So what is additional stuff that we need to do? Yeah, we have done already this. What is that? Mass properties of the part, rebuild the part. So this is the correct answer. Replace component. So we need to replace component and change our piston distance to 80. So first we need to angle mate should be eliminated now. Select angle, the suppress. And also question 10 is eliminated. So we need to change this first of all, and we need to rotate our part from this to this side, as you see, like that. So in order to do that, we need to select this. We should have parallel relationship. Let's suppress this as well. Let's turn the part around from here. Okay, this is fine. I'll fix this. So what is angle relationship? 15 degree from this edge to this edge. So this one and this one, there is a 15 degree angle between them. Click OK. See from top. Check this as well. Let's go to select sub-assembly, go to sub-assembly, and let's try to give the 80 millimeter distance between these two. Let's type 80 and enter. Let's click OK. Let's rebuild the part, go to main assembly. So it will automatically again will update it like that. Okay. From top view, we need to see top view. Okay, let's see our part. Coordinate system at 15 degree. So we should have 15 degree coordinate system at 15 degree to other side. Let's go to angle mate again. Yeah, 15 degree over here between this and this. So this is 15 degree again, the same version. So it's time to replace the component. So the component that we will replace is called base -B. We can move, and the easier way is to use the replace component. Let's go to base and right click. We should have a replace component over here. Replace components, and let's go to browse and base B and open. And click OK. Okay, we actually differ up. Okay, let's try to just isolate empty and made parts. Okay, we don't need to isolate at this point. We will do just a couple of changes based on this relationship. So let's go to coordinate system, edit coordinate system, because we need to define where our coordinate system is. Angle made. Let's edit angle made again. So we have replaced the component. We have missing face now. Click one more time. And concentric relationship. Let's edit feature. This one and also this edge. Edit. Click one more time. Let's edit this one as well. What else do we need to change over here? Actually, we don't need coincident relation. Oh, okay, we need coincident relationship. This face. Click OK. Click OK one more time. So this is our final assembly now. Should have 80 millimeter distance. 80 millimeter distance. I believe this is 80. Okay, but our part doesn't look like 15° because we shouldn't have that. We need to change it to this other side. We need to flip dimension. Select angle, edit angle. Let's flip dimension to this side. Let's click OK, click OK. Now this is the correct version. Let's check mass properties of entire assembly. Let's add and so we have completed our assembly, and these are the solutions that you can check for segments 3 and from question number 1 to question number 11. So question number 11, 104.28. So this is the correct answer.